Hey everyone, and welcome back. In this video you will learn how we can plot effective mode index in COMSOL Multiphysics. So I already have a solved model of a photonic crystal fiber, and I will show you how you can plot effective mode index, and I'll give you some tips how to extract the values to do further calculations, because for most of the calculations you either need the real component of effective mode index or the imaginary component of the effective mode index, right? So this is my model and I have my geometry I have studied and I have the result. So the result is ready and I'll show you how to plot the effective mode index, both the real and imaginary component. But before that, let me discuss a bit about what is actually effective mode index. So effective mode index is basically a fundamental parameter in the study of waveguide optics, particularly in photonic crystal fibers. It quantifies the phase velocity of light traveling through the fiber relative to the speed of light in vacuum. It is represented as N effective equal to C by V phase, where V phase is the phase velocity of light in the fiber and C is the speed of light in vacuum. N effective is crucial for understanding various properties of the fiber, such as modal dispersion, confinement of light, and the fiber's guiding characteristics. Now, the effective mode index of the design are actually affected by multiple factors, such as the geometry of the PCF. Basically, the arrangement, size, and the spacing of the air hole significantly impact the N effective. Material properties, the refractive index of the fiber material is also an important factor that affect the effective mode index, and further the wavelength of operation. So what is the different frequency or wavelength that you are working? So for example, in this model I am working from 1 terahertz to 4 terahertz in this model, right? So these are the different factors that affect the effective mode index. Now probably you might already know that the effective mode index consists two parts, the real part and the imaginary part. The real part of the effective mode index represents the phase velocity of light in the fiber. It determines how fast the phase of the electromagnetic wave propagates through the fiber relative to the speed of light in vacuum. In a photonic crystal fiber, the real part of the effective index is influenced by the periodic structure of the fiber, which alters the phase velocity due to the interaction between the light and the periodic dielectric material. This real component is crucial in determining the guiding properties of the fiber, including aspects like mode confinement and phase matching condition. And the imaginary part of the index relates to the attenuation or gain of light as it propagates through the fiber. In most standard optics fiber, the imaginary component corresponds to the loss due to the material absorption or scattering. However, in some specialized PCFs, this component can indicate gain if the fiber is doped or under certain nonlinear condition. So probably if you are working on photonic crystal and let's say your material contain a larger component of the imaginary refractive index, you will notice that after you solve the model, the effective mode index will have a larger component in the imaginary part. So that basically indicate that the attenuation is higher in the fiber, right? And also the non-zero imaginary component of the effective index indicate that the fiber is either absorbing or amplifying the light, which is essential for application in fiber laser or sensors. In most cases that I've observed over the years, including a ton of designs in all the domain in the electromagnetic spectrum, including the terahertz domain, is that the imaginary component is generally small if you make a good design. And let's say if you're working on communication systems, for example, if you want to develop a fiber that supports a multimode application and you want to transmit data across a longer length, then you might wish to have a lower value of the imaginary component. In all those cases, you would want the design to work in such a way that the effective index, that is the real component, is higher and the imaginary component is as low as possible, right? So these are the different physical aspect of the index. So now let's try to plot the data. Now I have a solved model where I have solved from 1 terahertz to 4 terahertz, and I'll just click on all. So what does this all mean? Let me just explain everything in this area. Okay, so this is the model builder that you all know. It contains all the detail of the model, and in the settings here, the first is the dataset. So dataset means, let's say you are working on a model and there are multiple studies, and even within a study there can be a parametric sweep, or maybe a different kind of parameter solution, or you have disabled the parameter and you have run a separate solution, and so on. Those are basically the dataset. Okay, so these are basically the data that you will plot in the model. And parameter selection, depending on the data set, the software will automatically update this part of the settings, where let's say in the parametric solution 2 I have set the parameter f, that is frequency, from 1 to 4 terahertz. That's why you can see that I have frequency from 1 terahertz. As you can see in the bracket, it's written THZ, that is terahertz, to 4 terahertz. So I'll select all. That means when I click on plot, all the frequency datas will be analyzed to give me the plot. Now in the effective mode index selection, out of the 4 mode, I've chosen the first mode to plot in this diagram. And this is the expression. By default, when you type ewfd.neff, this basically means the real component of the effective index by default. And also you can just write real, put a bracket, so this also means the real component of the effective index. And if you click on plot, since this is a big file, I have all the calculations done, so it might take some time. Probably this file was more than 2 GB, I guess, but yeah. So this is the plot for the real data. Now let me change this to imaginary. To plot the imaginary component of the effective mode index, you just type imag and click on plot. You might have to wait a few seconds depending on the size of your model and the wavelength or frequency domain you are studying. And now you can see the y-axis is the imaginary component of effective index, and the x-axis is the wavelength in millimeter. So let me explain what is going on here. So IMG stands for the imaginary component, EWFD is the physics. Okay, so for example, as you can see, whenever you are working on a physics, in the bracket the physics code will be written. So EWFD is the physics dot NEFF. So inside this physics we have this function effective mode index that is being plotted. So if you are working on a complicated model, then you might have like 3 to 4 different physics. Then in that case it could be EWFD2 or something like that. And if you are creating a custom physics for your model, then it will be the custom physics name dot NEFF, something like that. Okay, now let us jump on to the x-axis. So in the x-axis I have written the wavelength, and the unit I have chosen to be micrometer. So the x-axis is in micrometer. Now I can always change this to F and to terahertz, and I can click on plot. Again, it might take few seconds. I'll just pause the video. So you can see that since my model was studied from 1 terahertz to 4 terahertz, I have the data of the imaginary component across the range, and you can see that I have a dip around 1.3 terahertz. So probably some kind of sensing activity is going on in this range. So this is one of my work that I was working on photonic crystal for sensing action. So basically this is how you plot the figure. And again, if you want to change the line style and the color style and so on, this all can be done in this region. And if you want to plot the real and imaginary component together, you can do that. So you can just type real and imaginary and you can click on plot. So whenever you have multiple y data, it will by default plot together, and probably you will have the same y-axis, so the scaling might not match because the two values are well separated. The imaginary component was close to 0 and the real component was close to 1.7, right? That's why it looks like two different lines. But you can always come back and you can click on 2 y-axis, and what you can do, you can just duplicate this, and I'll just cut the real part and I'll just delete this. So what I did, basically I have one global plot as the imaginary plot and the second global plot as the real plot. Now if I go back here, I will choose the global 2 as the secondary y-axis, and now I'll click on plot. I will again click on pause because it might take some time because the model is large. So yeah, this is done. So now you can see that there's an arrow, okay? So global 1 is the imaginary component of the effective index, which is marked by the blue solution, and the green one is the real component, right? Because it has the higher value. So in the same plot itself, you can just understand what is going on. So whenever you're working on a study where you need to visually understand what is going on, then you can do this feature of 2 y-axis plot in COMSOL Multiphysics, and you just create different plot and then select that particular plot which you want to show on the secondary y-axis. So this is how you plot the effective mode index in COMSOL Multiphysics. And of course, if you want to copy the data or export the graph, you can just click here to take a image snapshot, or you can always right click and click on copy plot data to clipboard. You can then paste it to Excel, and you can check one of my tutorial where I showed you how to export data from COMSOL Multiphysics. That link will be there in the description. And also I have my courses that you can check in the description if you want to learn a complete workflow how to use COMSOL Multiphysics to run a model. Thanks for watching. If you like this video and the quality of the video that I am trying to work on, then do support this channel. Subscribe, give a like, and comment your thoughts how I can improve. Maybe you can ask any question. If it is answerable in the comment section, I will definitely try to answer your question. Thanks. Have a nice day ahead.